Hi guys, this video is going to be a tutorial on how to do monohybrid and dihybrid crosses. So monohybrid crosses should be familiar to you, but dihybrids are probably going to be a new subject. So let's just get started with a simple monohybrid cross. So we're going to work through a couple problems, and this should help you as you go through your practice problems in your booklet. So in peas, a homozygous tall plant is crossed with a homozygous short plant, and we know that tall is dominant. So a homozygous tall plant, if we use the letter T, would be TT, both capital, and a homozygous short plant would be lowercase t. It's really important when you are doing Punnett squares that you choose letters that are very easy to distinguish between capital and lower cases, things like O's, S's, they really don't work so well. So T is a great example because it's a very clear difference. So we just did number one, what are the genotypes? So now we want to know the genotypic and phenotypic ratios of the offspring. So to do this, we have to do a Punnett square. So we'll put big T on top, little t to the side, and then you just fill it out. So for this situation, the genotypic ratio, so for number 2, is going to be all big T, little t. And the phenotypic ratio, we know that if there's at least one capital letter that plant is tall. So for number 3, all tall. If we do it in percentages, simple enough, 100%. All right, let's do another example. This time we're going to talk about tigers. So in tigers, orange and black fur is dominant to white and black fur. So a heterozygous tiger is crossed with a heterozygous tiger. Well, we know that hetero means different, so let's choose letter B for these guys. So orange and black is going to have at least one capital B. White and black will be two lowercase b's. So if they're heterozygous, they are big B, little b. So both parents are big B, little b. And once again, to do our ratios, we're going to have to do a Punnett square. So big B, little b, big B, little b, oops, big B, big B, big B, little b, big B, little b, little b, little b. So genotypic ratio. So this time, we're going to have a bit more to write. So we're going to have 1, big B, colon, 2, big B, colon, 1, little b. And you always want to write these in order of most dominant to least dominant, and always label your numbers. No naked numbers. You should never have 1, 2, 1. You should have it labeled. All right, so for phenotypic ratio, this one here is orange and black. These ones are orange and black, and this one's white and black. So for our phenotypic ratio, we're going to write it below. We have 3, I'm just going to do O/B for orange and black, and 1 W/B for white and black. So if we do this into percentages, up here for number 2, it should be 25%, 50%, and 25%. And down here, and that's a 3, this is an OB. So we should have 75% and 25%. All right, so those should have been simple and a review for you. Now we get into dihybrid crosses. So dihybrid crosses are more than likely new for you. So this is when you want to determine crossing 2 traits at the same time. So Mendel wanted to determine if traits were linked or not, so he invented dihybrid crosses. This also concluded the law of independent assortment. So this time we're going to practice. So we should have 2 traits in our problem, and we do. So we have freckles are dominant to no freckles, and abundant body hair is dominant to little body hair. So we'll use F for freckles and little f for no freckles. And then we'll use a capital H for lots of body hair and a lowercase h for not very much. So Jim, who is heterozygous for both traits, marries Nancy, who is homozygous dominant for freckles, but recessive for body hair. So Jim is going to be big F, big H, little h. And Nancy is homozygous dominant for freckles, so she's 2 big Fs, and she's recessive for body hair, so 2 little h's. Okay, Now we want to know the genotypic ratios of the offspring and the phenotypic ratios. So in order to do this, we first have to figure out what is going to go on the top and the sides of the Punnett square. Now, to do this, you use the FOIL method, okay? So let's look at Jim. So he's big F, oops, oh boy, sorry. He's big F, big H, little h. So big F goes with big H, big F goes with little f goes with big H, and little f goes with little h. So Jim is going to give the 4 different alleles. So let's make our Punnett square. And bear with me, this might be kind of tricky to write in these little boxes I'm about to draw here. All right, so Jim is going to be big F, big H, okay? Then he's also going to have big F, little h, big H, and little f, little h. Now, Nancy only has 2 options, not even 2, just 1, because she has 2 capital F's and 2 lowercase h's. So all of Nancy's alleles are big F, little h, which is actually going to make doing this Punnett square a lot easier. So when we do it, we want to keep the letters, like letters, together, so the F's will stay together. And then you want to put them in order of capital first, then lowercase. All right. Now, you may have caught on that we really don't need to do these because they're exactly the same as above. So, genotypic ratios. All right. Our genotypic ratio is going to be 4 big F, big H, little h. We're going to write below it, or we'll keep going. 4 big F, little h, colon, will come down below. 4 big F, big H, little h, colon. 4 big F, little h, little h. Now, 4s are not reduced. So when you're writing this on a quiz or a test or even a homework assignment, you need to reduce these 4s to 1s. So they can all be reduced. So it should be 1, 1, 1, 1 should be your ratio. Now, our phenotypic ratio is going to be a little different because we have to look at what those traits will represent. So this one here, that is going to be freckles and hairy. This one here, oh, also freckles and hairy. This one, freckles and no hair. And this one, freckles and no hair. So we're technically, if you were to count up all these squares, you would have 8 freckles, hairy, to 8 freckles, no hair. Sorry for the writing once again. And we can reduce that to be 1 to 1. So the last question then, what is the chance of their child being freckled and hairy? Well, 8 out of 16, 1 out of 2, or 50%. And whenever it says chance, give me a percentage. All right, let's do another one. So widow's peak is dominant to a straight hairline, and long eyelashes are dominant to short eyelashes. So for widow's peak, we're going to choose I because W is one of those tricky letters. And then for eyelashes, we're going to do E. Okay, so Dave, who is heterozygous for both traits, marries Julie, who is heterozygous for both traits. So the genotypes of the parents. We know that they both have 2 lower cases and 2 capital letters, 1 of each. So they're both going to be the same. And this is going to give you, actually, at the end, a very common ratio that you're going to need to memorize. So let's do that Punnett square. If you remember FOIL, I with big E, I with little I with big E, little I with little e. Try to make it a little bit bigger this time. All right, so they both are going to give the same alleles. And if I were you, I'd pause it here and then give yourself a minute to fill this out and then check your work with what I have. All right, So check your work, and this should have been what you got. Now, with the genotypic ratio for a cross like this, first of all, I don't really have that much room on here to write it out, but I have confidence in your counting ability, so we're just gonna let you count it, and we'll see what you get. So go ahead and count that up. And then the phenotypic ratio, though, is what we're most concerned with. So the phenotypic ratio is always going to be, when you have two parents that are heterozygous for both traits, the phenotypic ratio is always 9, 3, 3, 1. Always. Always, always, always. So that actually saves you a lot of work on something, say, like the EOC, where you have to do a problem like this, and you're like, oh my gosh, I don't have enough time to do this problem. Well, guess what? You already know the ratio is 9, 3, 3, 1. So the 9 is going to be both dominant. So that would be a widow's peak and long eyelashes, and we're just going to abbreviate. So then for the 3s, each 3 is going to have one dominant and one recessive, and then the other 3 will be the opposite. So the first 3 we'll say will be widow's peak and short eyelashes. The other 3 will be no widow's peak and long eyelashes. And then the 1 is the only one on the whole thing that's double recessive. So that's going to be no widow's peak and short eyelashes. So, on the sake of a test or a quiz, I'm not necessarily going to make you show your work on a dihybrid cross. There may be a time where I may have you do it just so you can prove to me that you understand how to do it. But otherwise, if you see this ratio, you know that it's 9, 3, 3, 1. All right, so let's see. Let's do this. In a dihybrid cross, big S, big Y, little y crossed with big S, big Y, little y, what fraction of the offspring will be heterozygous for both traits? Now this requires a little more work because this is looking at, you want to look at the genotypic ratio. So we're going to cheat a little bit. We're going to go back here. So when you look at this screen here, because this is the same mix, you have 1, 2, 3, 4, and then, let's see, do we have any more? All right, so we only found 4. So 4 out of 16, which reduces to 1/4. So the correct answer is D. All right, we'll do another one. So this one, same thing. Both parents are heterozygous. So what fraction of the offspring will be homozygous for both recessive traits? Well, we kind of talked about that. Let's go back here. There's only one that's going to be double recessive. So our correct answer is 1 out of 16.